Application problem 4 on slopes and lines. The distance time graph is shown in front of a motion sensor. And then based on this graph, there are 4 questions here. I'd like you to read the questions, understand, and then answer them. Stop the video meanwhile, and then look into my solution. A. Identify the d-intercept and explain what it means. Identify the t-intercept and explain what it means. Calculate the slope and explain what it means. Explain why the terms t-intercept and d-intercepts are used. Well, this is a very interesting problem, and it is more on communication. Now, as you can see, the independent variable here is what? Is time in seconds, which we are giving t, right? T denotes time in seconds along x-axis. And along y-axis, we have distance, d, in meters, correct? So in general, we have the term x-intercept and y-intercept. Here, we are using d-intercept and t-intercept. Reason simple. The x-axis is now changed to time, right? We are saying t is along x-axis, the horizontal axis, correct? So we'll call it t-axis, and the normal y-axis has been named as a distance d-axis, right? So wherever a line of the graph distance versus time crosses time axis, we'll call it t-intercept. And wherever the graph of distance versus time crosses distance axis, we'll call it d-intercept, correct? Now answer the questions. I hope it has more meaning now, right? Now, if you look at the main question, the distance time graph. So this is a distance time graph is shown in front of a motion sensor. So imagine that there is some object here, and let's say here we have a motion sensor and the object is moving away or towards the motion sensor. So when we say this particular point, what does it mean? It means that when time is 0, that means the starting point or the initial point, the object is 5 meters away from the motion sensor. And as it gradually comes down to 0, that means in time 10 seconds, the object reaches the motion sensor. So basically think like this, that here we have a sensor, right? And the object is moving. So this is from where we are doing all the measurements. And think that all the motion is taking place along a horizontal line. And initially at t equals to 0, the object is here. So this is the point where t equals to 0, starting point. So what happens? At t equals to 0, object starts moving towards the motion sensor like this. And in 10 seconds, that means at t equals to 10, it reaches this point where the motion sensor itself is. Do you understand? And this total distance is 5 meters. This distance is how much? This distance is 5 meters. Do you see? This is how the situation is. And what does this straight line shows? It shows the speed, distance over time. So when we find slope, rise over run, so this is the rise, do you see? And in this case, the rise is negative, right? And the run is always positive. In this case, positive. So rise over run will be negative. That means the velocity is negative. It is approaching, not going away. I hope you got the concepts, and now you can again try answer these questions. It's a good time. You can stop my video now, make second attempt, and then look into the real answers. Okay? Okay. Now identify the d-intercept and explain what it means. D-intercept is this point, which is 0, x value is 0, and y value is 5. So the d-intercept is 0 and 5, correct? So explain what it means. It means, as I was saying, that at the starting, the object is 5 meters away from the motion sensor. Okay, so the object is 5 meters away. So here the distance d equals to 5, right? So object is away 5 meters away when the readings have been just started. Identify t-intercept. So t-intercept for us is this point, which is 10, 0. So I'll write t-intercept as 10 and 0. Explain what it means. T-intercept means when was the distance 0. Do you see? Distance is 0. Do you see that? So it means that after 10 seconds, the object was at the motion sensor. That's what it means. Do you see? Here, distance equals to 0. So object was at the motion sensor. So initially it started 5 meters away, and after 10 seconds it reached the motion sensor. This is what it means. Calculate the slope and explain what it means. Slope is rise over run. So here you could do from these two equations also. 5 minus 0. So we say 5 minus 0 divided by 0 minus 10. 0 minus 10, which is 5 over minus 10, which is minus half. And what are the units? Rise, that means meters, and time is in seconds. So it's meters per second. So minus half meters per second. And this is change in distance over change in time. So we'll write change like a delta, means change in distance over change in time. Right? And that gives us speed, right? So speed is the object is approaching, right? So we say we can call it velocity. Velocity is negative half, that means 0.5 meters per second. So object is moving with the velocity of 0.5 meters, half meters per second towards the motion sensor. It's not going away from it, towards, and therefore we get this negative symbol. Okay. D. Explain why the terms t-intercept and d-intercepts are used. I answered this question right in the very beginning. T-intercept because our horizontal axis is t, not x. So the line which crosses the horizontal axis will be called t-intercept. Our vertical axis is d. So the line, the graph of our line crosses d axis. Y-axis here is named as d-axis. Vertical axis is d, not y now. Okay. Therefore, that is called d-intercept, right? So d-intercept is a point where the d-axis, which is the vertical axis, is being crossed by the line. At that point, time is 0, right? So this is our initial distance from where the object started. So explain why terms t-intercept and d-intercept, because our horizontal axis has been named with time t and the vertical axis has been named by distance d, and therefore we are using these terms. Okay, we are not naming them x and y, we are calling them t and d. I hope you understand and enjoy this. Thank you.